Okay, so if nobody has no objections, I have started the recording. Mikhail, please start recording to the cloud, so just to make sure we have everything. Okay. Okay, I see. Okay, so Mikhail, have you posted?
No, I'm looking for a description and so on.
It's in the document. Just you're looking for another kind of description. I will provide it shortly. Okay, so please post it, and let's start from this moment. This is point 0. Okay, so George, I see you're participating in many different activities. Like I know you're Java champion, author of 6 books and hundreds of best-selling videos. At the same time, you contribute to Spring ecosystem and to projects like Spring Boot, Spring Integration, Spring Cloud, and many others. Drives a Beautify podcast and YouTube channel. Can you please explain how do you manage to do all of it? Because I see there are many activities, and how do you spread your time across all these things?
I don't know. That's a good question. I used to travel before the pandemic, before the virus, I used to travel as well, 650,000 miles, which is about 1 million kilometers every year. And so I think that helped because it gave me a lot of free time on flights to do work, There's something very nice about having dedicated quiet time to work. Maybe that's it. I don't know. I feel very lucky. My commute, my commute used to be, 15 hours or something like this. So
yeah, I see. When you have spare time and you're during your flight, that's absolutely fine to do something that requires us to be very focused. But what about our current pandemic time? How do you manage to do it when you have to spend almost all your time at home?
Well, I mean, Spring is easy, right? Like if I can do Spring, anybody can do it, right? It's very productive. So I just let it do the work for me. And then I have to write it down. It's not such a big deal there. I think it's been useful over the years to learn how to develop muscle memory so that things become automated. So for example, I write a blog every Tuesday called This Week in Spring. To put that blog together, I have written little agents, little things that mine information from different places, and it gives it to me in a report. And I'm like, okay, I can use this for my report. When I publish my podcast, there's like 10 steps. I got tired of doing all that, so I just put it all in a software process, and then that's now I just record the interview and the opening, and I send the files out, and the process automatically puts them together, adds the music, publishes them, synchronizes it, puts a picture and all that stuff out there, etc. So you start writing software to automate parts of your life, and it becomes easy. I was writing a book. I wanted to write a book, and I wanted to use ASCII Doctor, so I wrote Beautiful ASCII Doctor, which is a set of software. It's a Spring Boot pipeline that will make it much easier for you to create your own book. So now you're not worrying about using Word files or anything like that. Software is powerful.
Yeah, I know. Thank you very much. I suppose everybody who wanted to join has already joined. Let me start this session. Hello, dear friends. I'm very happy you joined our session today. My name is Alexander Barmin. My co-pilot is Mikhail Fisenko. This week we are talking about event-driven architectures. However, today we have a special guest. It's Josh Long from VMware, who will talk about microservices this week. It's a great exception, but it's a very honorable for us to have George with this event. As I have already mentioned, George is Spring developer advocate since 2010. He's a Java champion as well. And I suppose we're almost ready to start. Dear attendees, don't forget to post your questions into the Q&A session into the Zoom application. At the end of the talk, your questions will be asked. If you want, you can write your questions in Russian. I will translate them. No worries. So, George, the stage is yours. Let's get started and go ahead. Thank you.
Thank you so much. Spasiba. I appreciate it. I appreciate all of you for coming here as well. I know that there are a lot of places you could be, a lot of things that you could be doing, and you chose to hang out with us. That makes me feel very happy. I wish that we could be somewhere together in person. Obviously, it's been a while since that's happened, but maybe one day. All right, my friends, here are my slides. I wrote them for you. I hope they are helpful. These slides contain all the coordinates that you need to care about with respect to this one talk. You have my name. Well, no, you don't actually have my name. I think you figured out my name by this point, but there, I'm gonna improve the slides. So you've got my Twitter handle, you've got my LinkedIn, my email, my podcast, my YouTube series every Wednesday. That's a new episode. The code for this presentation is github.com, Kubernetes native Java. I'm on Twitch. I have a blog, just all this stuff. So take a screenshot of this. I worked very hard on these slides, and I hope that you can appreciate them for what they are. All right, my friends. So what we're going to do today is we're going to talk about how to build software that works well in production. And of course, today, more often than not, production is Kubernetes, right? And so we're going to talk about what it means to build software that takes advantage of Kubernetes. Obviously, people are moving to production all the time. They care about moving to production more quickly, more efficiently, more safely. And so they look for ways to go faster. They look for ways to automate the movement of concepts all the way to the customer, right? How to take an idea and iterate upon it and see it delivered into production where the customer can benefit from it. Obviously, the faster you can do this, the faster you as an organization can iterate. And so people are looking for ways to improve their velocity. They look for ways to improve their velocity because they want to learn quickly. And so they look at their organization and they realize that all the different things that we do in the organization in the last 20 years, there's been a profound focus on improving the speed, the agility at which we deliver software. So things like cloud computing, microservices, continuous integration, continuous delivery, test-driven development, all of these things are not new. They're not technologically new, right? We had the ability to deploy servers 20 years ago. We had the ability to do tests 20 years ago. We had the ability to do automated to do some of these things in a fairly repeatable fashion, but they were painful and they were slow. And so really the main thing that you see from all these is that we've automated them so that we can do them repeatably and get consistent results quickly so that we can take them for granted and then move more quickly in response, right? That's the important part here, is that we've got tools and processes that allow us through consistency to achieve velocity. And this is good because it allows us to learn, like I say, to respond to the feedback that we get from being in production. So there are several things that you can do in your organization to improve that. We already talked about some of these things that you can do. One thing that people find when they're building software is that they have large groups of people working on a large code base. And the larger the code base, the larger the group of people, the slower your organization becomes. And this number at which you become too slow, it's very hard to define. It's not an exact number, but I have found, and I think you will find, that that number seems to be 5, maybe 6 or 7 different people. 5 or 6 or 7 people is about the size at which it becomes difficult to keep in your head what everybody else on the team is doing. Amazon here in the United States, very famously, they talk about a 2 pizza box team, a team that is small enough that you can feed everybody with but 2 boxes of pizza. And that's, again, 5, 6, 7 people, right? It's just something about the ability for you to keep state in your head, right? Have you ever been to a stand-up meeting in the morning and it's like 50 people? Doesn't that feel too big? I don't know what the right number is, but it's certainly, that's too big, right? You can do it, but it's very hard to keep it quick, to keep everything moving quickly when you have 50 people in a stand-up. So we look for small teams. Well, of course, this is hard if you have a large code base. And so teams look for ways to break apart the code base. And when they do this, they can't just start cutting it randomly. They have to have natural places along which to break it. If they look at Eric Evans's amazing book, Domain-Driven Design, they can find the idea of a bounded context, a part of the domain model that stands by itself, internally consistent, reusable, independently deployable. And this is very important here. A bounded context is something that you can think of, that you can work with without being dependent on other parts of the domain. And if you divide your code base, then you need to be able to deploy those code base pieces independent of other parts of the code base. And this means a service, a network service, not a DLL or .jar or something like that that is linked at compile time to something else. And so if you have a service, it's easy to now change one thing without having to change the other, right? These are independent of each other. The problem, of course, is that if you have services, you now have network communication. That network communication is a problem because it means that things will fail. You have more moving parts. Microservices are not a free lunch. There are problems that you encounter when you move to this architecture. However, it's still worth it, right? It's still worth it because you get the benefit. You get the benefit of agility, and there are ways to pay down, to reduce the cost of some of those problems. And so today, my friends, we're going to talk about some of the things that you should be aware of when you build software intended for production using Spring. And as always, to do this, we're going to go to my second favorite place on the internet. My first favorite place, of course, is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It's better than Disneyland. But if you haven't been to production, you can begin your journey here at start.spring.io. And what we're going to do is we're going to build a new application. I'm going to use this, the reactive web support. I'll use the H2 embedded SQL database. I'll use R2DBC. I'm going to use the Spring Boot actuator. And I'm also going to bring in the Spring Native support. Now, Spring Native gives us support for creating GraalVM native images out of our applications. I'm using all the reactive stuff. This is all brand new reactive stuff, right? Well, fairly new. But the goal of Spring Native is to take existing applications written 10 years ago, for example, and also to make them work as native GraalVM images. And so, or 15 years ago, right? We want to support lots of different workloads with this, not just the new stuff. And so GraalVM is a very interesting prospect. They just released Java 17 support for GraalVM, but unfortunately, Spring Native doesn't yet support that. So down here, my friends, we have 3 choices, but only really 2 usable choices. The choices of what version of Java we'd like to use. We can use Java 17, which we should absolutely use in most cases, as it is the current long-term supported version of Java. We can use Java 11, which is the last long-term supported version of Java. And we cannot and should not use Java 8. Java 11 and Java 17 are faster, more syntax rich, more performant, more secure, more scalable, more operations friendly. In every way, they are technically superior. They're also morally superior. Trust me, my friends, you won't like the look of sadness and despair in your children's eyes when they see that you're using Java 8 in production. Don't do it. Be the change you want to see in the world. Do the right thing. Use at least Java 11 if you're using GraalVM and Java 17 otherwise. So I'm going to go ahead and give this service a name called customers. It's going to be a microservice to deal with customer data. And basically, with that done, I'm happy with my selections. So we'll open this up in the IDE. Here we go. Now you can use any IDE. The language server for Visual Studio Code just turned 1.0 for Java. So that's very powerful. You can use that. I'm using IntelliJ. That works just fine. The Spring Tool Suite works great, of course. So lots of different options here. Okay, so let's see here. We're going to open this up in my IDE. And again, it's just a public static void main Spring Boot application. I'm going to build an application that writes data to a database. So I'll say private integer ID, private string name at ID. And this is going to have some data in it. So I'm going to create some getters and setters and toString and equals and hash code. I'm going to add Lombok. Lombok is a compile time annotation processor. Normally I go to the browser here and I also add Lombok, right? Lombok is easy to add there. I should have just done that. And that's fine, right? So I'll just paste that there. Maven, reload project, etc. Okay, so now with that there, I can add these Lombok annotations to create getters, setters, toString, etc. Now I want to save and work with data, and so I'm going to create a reactive CRUD repository. Reactive programming gives us three big benefits, right? One is it is much more efficient use of threads, and so it's much more scalable. It makes it so that the cost of using threads is less because we're not so greedy with the threads. We share the threads efficiently, right? It also gives us a single abstraction, a single type. And because we have a single type, we can easily add retries and timeouts and error handling in a consistent way across all of our code. And also because we have a single type, we have something that we can compose. We can compose easily, right? So if you're dealing with Apache Kafka or web services or REST or WebSockets or RSocket or GraphQL or whatever, it's just one type. It doesn't matter if the data is a small amount of data or if it's a large amount of data. It doesn't matter if it's coming slowly over hours or if it's all coming at the same time. You have just one type, and that means it's easy to glue these things together. You can forget or unlearn so many of the other APIs that you used to have to deal with to integrate different sources and syncs of data. So for example, imagine you wanted to take data from Kafka and then send it out via WebSockets. It's not hard, is it? Right? You could probably figure it out, but they're completely different APIs. You've got a thing that you can use to read the data. Maybe it's an asynchronous callback kind of thing. And then you've got another thing that's going to produce WebSocket data. They're not meant to talk to each other. They're two different APIs. But when you use reactive streams, they're the same API. So it's very easy to say, I'll take the stream of data coming from here and send it over there. I don't have to do anything to it. There's no glue code. I'm not adapting the API and doing all that. And this makes the work of building distributed systems and services much easier because you don't have to, you're not in the business of writing all this boring error-prone glue code. So I'm using the reactive CRUD repository. It's very similar to a regular repository. It's just it supports reactive method. Okay, we're going to create a controller here, a controller that returns our data. It's going to be a REST controller, not an MVC controller. So I'll use @response_body, and I'm going to inject the customer repository. Okay, and we'll inject that here. Publisher of customer, get customer dot find all. Okay. Very good. So I'm going to inject this into the constructor thusly. And there's my customer repository. And now I want to start this application up, but of course I don't have any data. So I will create a schema file, schema.sql. I'll say create table customer ID serial primary key name var_char 255 not null. Okay. And I'll create a new file here called data.sql. And in this, I'll insert some records. I'll say insert into customers, some people that are on the Spring team. Obviously, I'm on the Spring team. I'm very grateful for that. Olga, she is on the Spring team. Yushin, she is on the Spring team. Stefan, of course, is on the Spring team. Dr. Sayers, of course, on the Spring team. Violetta, she's on the Spring team. Who is that? 7. We need Spencer, right? Who else is on the Spring team? I like 8 names, so that's Josh. Oh, Jurgen, of course, right? There we go. There's 8 people on the Spring team. So let's go ahead and restart the application and see what we get. Oh, do I want to enable Lombok? Yes, I do, please. Okay, let me see here. Restart. Okay. So localhost customers. Voila. There's our data. Are we done? Are we ready to go to production yet? No, not quite, right? Because obviously building a REST API is not interesting. That's not the hard part. That's not what we're here to do, right? This is very efficient. You know, that's nice. You know, it's going to give you the most efficient use of your JVM, but that's not what we're here for. What I want to do is I want to talk about what it means to get this into production. And so obviously there are some things I need to care about, in particular, observability. Observability is the ability for my system to, at runtime, articulate its own state, right? To explain what it's doing and why it's doing it. And to support that, we have the Spring Boot actuator. The actuator is a set of managed HTTP endpoints that gives us information about the state of the application. Because remember, in production, nobody can hear your application scream, right? You have to like give it the ability to articulate, to speak out about its own state. So I'm going to enable a few things here. First, I'm going to show the health endpoint details. I'm going to expose all of the actuator endpoints. This is good for a demo, not good for production, right? You don't want to do that in production. And I'm going to show all the details for the health always, as opposed to just when it's authenticated or never, okay? And I'm going to use the Kubernetes readiness and liveness probe. So let's go ahead and restart all that. Did I restart? Yeah, I did. Okay. So localhost /actuator. There's my managed HTTP endpoints. I go here, actuators, beans, caches, health, info, etc. And you've got information here that you can use to identify the state of the service. Things like the HTTP endpoints and the handlers for them. You've got the scheduled tasks, which shows you all the different tasks that have been scheduled. The metrics endpoint, which is powered by Micrometer. Micrometer is a vendor-neutral application metrics facade that you can use to talk to App Optics, Azure, Netflix Atlas, CloudWatch, Datadog, Dynatrace, Elastic, Ganglia, Graphite, Humio, InfluxDB, JMX, KairosDB, New Relic, Prometheus, SignalFX, Google Cloud Stack Driver Trace, SatsD, and Wavefront, among other things. So it's very, very powerful, right? And it's an abstraction, so you can just plug in a different implementation. And the nice thing about this is it gives you, it gives you statistics like the count, the total time, the max, etc., and different dimensions of data. So I can say, show me all the count for the method get, or maybe post or delete or something like that. So I like the metrics endpoint, and you should definitely use it to both show the information here and to publish that information to a time series database, which can be showed as an aggregate across all of your services. We've also got the thread dump, which gives you, a thread dump. You've got heap dump, same thing, gives you a heap dump. Loggers gives you a listing of all the different endpoints that have been configured, and you can post to this endpoint to change the log levels of your applications. We've got info and health, which we'll come back to in a second. We've got caches that show you all the cache managers, beans, which shows you all the different Spring beans and their types and the dependencies and the relationships to each other, their scopes, etc. So a lot of stuff here. Now let's talk about two different specific endpoints. Info is empty. It's up to you to put information about the service itself. So I can say info message equals hello world, right? I can add that, no problem. I can add whatever I want. I can say info dot, ID equals 1. I don't know, anything you want, right? You can also automatically add some things about the current build. So let's say I want to go to my Spring Boot plugin. I'm going to look for the git commit ID plugin here. That's this dependency, this plugin down here. And I can go to my build down here, plugin, all right. And there we go. I'm just adding this plugin to my build, nothing special. And what it'll do is it's going to see that I've got a Git repository. So let's say git init, git add, git status, git add.mvn, git add.gitignore, git commit -a -m YOLO. Okay. And then I'm just going to build this. I'll say true clean package. Okay. Very good. So, Java, I'm using Java 17 here. So SDK list Java. And I want to use, let's see, SDK list Java. Okay, so I want to use Java 11 or at least Java 11, right? So let's see. Oracle 17, OpenJDK, come on. This is so confusing these days. It has gotten a little out of hand. Here we go. This is the version of Java I would like to use. SDK use Java. Okay, and I'm going to go to the customers directory here that I've created, Maven clean package. Skip tests. We're going to compile that code. And all that's going to do is it's going to see that we're in a Git repository. you can see it says do git repository, and it's going to capture information like the git commit hash, the ID, etc. And it's going to put that in the target directory. So I can close this now. And if I refresh this, generated classes, git.properties, all that stuff is there. Now I can restart my build with that file on the class path. I don't even care about this build anymore. It's irrelevant, right? I just want that property file. Go here, and then ta-da, you've got information about the current build. So imagine you do git commit, git change, git push, and then it goes to a CI environment and then to a continuous delivery environment like Flux or Argo or something like that. And then it gets deployed into production. Well, now you need a way to understand what version of the code is in production. And it's very easy just to go to the actuator endpoint and say, oh, okay, this build was triggered by this commit ID. You might also be able to look at the deployment for Kubernetes and look at the Docker image and maybe have the tag point to the same commit hash or something like that. But at least now your application itself tells you where and when it came from, right? And if there's something wrong, you can say, okay, let's get bisected that particular version. Okay, we've also got the health endpoint. The health endpoint gives you a listing of your components that if they were to fail would mean the service itself is sick. So the disk space and the connection to the database is there. You've also got the readiness and liveness probes. So in Kubernetes, the readiness probe tells Kubernetes whether your service is ready to be put into production, and liveness tells Kubernetes whether your service should stay in production. You can of course change this. You can actually toggle that state. So let's say health controller, right? Response body, post mapping, right? Down, mono void, down. And all I'm going to do is I'm going to inject a pointer here to the application context. And we'll inject this in the constructor. Okay. And this is a reactive type. I'm going to say availability change event dot publish this dot context liveness state is broken. All right, so there's that, and I'll say return mono dot empty. It's fine. Okay. Okay, so we can restart this. Let's go ahead and restart. Good stuff. And we say curl x host HTTP localhost 8080 down. Now, before I do that, let's say curl HTTP localhost 8080 /actuator /health /liveness. Okay, so it says up. So now let's do curl -x host HTTP localhost 8080 /down, and there it says down, right? So I sent the down signal, I published an application context event, and instantaneously it went down. Now, what happens when it goes down? Well, the container orchestrator, if you configure your deployment or your pod to have a liveness and readiness check, the container orchestrator will check that endpoint. It'll see the status code 500, and it'll start to terminate that pod and then create a new instance of it. The question then is, what should it do when it kills your pod? Should it wait, or should it just kill it instantly, right? And that's what we mean when we talk about graceful shutdown. So how do I want to shut the application down? Do I want to do so immediately, which will be basically sig term and then sig kill, or do I want to do it gracefully? This will give me a little bit of time between the sig term and the sig kill to clean up my application state, to stop accepting new requests, and to finish any existing work, and then shut down gracefully if I have any in-flight transactions. So I could specify, for example, that I have a timeout per phase of, let's say, 30 seconds. You need to specify this in your Kubernetes deployment as well. But the point is, this combination allows you 30 seconds to gracefully finish any in-flight transactions and then shut down if you have any, right? Okay, so this is a very convenient thing here. Some of these things are Kubernetes specific, right? And so you have to consider some of the things that are related to Kubernetes specific, right? So, for example, I want the health endpoints. I want that to be there, but I don't. All this other stuff let's see, I want to keep that separate, right? So I'm going to use this new syntax, hash triple dash, right? And I can say activate on cloud platform Kubernetes. So all this configuration after this dash triple hash will only be accessible when we're inside of a Kubernetes application. And so when we deploy this into a Kubernetes application, it's automatically detected. You can also force it to be, to act like it's a Kubernetes platform by using this property. So you can test it on your local machine. This is very convenient because now you can have configuration that's only there for Kubernetes itself. You can also create Java beans that are conditional on the cloud platform. So cloud platform, Kubernetes, application runner, runner, turn args, system out, running on K8s. Okay, good. So there's this very simple thing. Now, good. There's my dynamic Kubernetes specific configuration. So let's run it without the Kubernetes flag. All right. Okay, here we go. And if we go here, it's what did we say? We said it's on port 8080 / and then well, there's no liveness and readiness probes. Go there, right? It doesn't exist, right? These configurations don't exist. Let's add this property, and you can also put this property as an environment variable or a -- flag or something like that. So I can do let's see. Allow okay, program arguments, add this in here, -- okay, hit apply, hit okay. And we don't need this here, we just restart. Okay, so good. And you can see we got the Java bean running on Kubernetes. We get this now, we go here, we got liveness and readiness probes. So we can easily build applications that run in Kubernetes. And that's great because I want to go to Kubernetes. So we have two problems that we have to think about before we can get to Kubernetes. First of all, how do we get into Kubernetes? Well, we get in there via a container, right? And so something has to containerize our application. And this is where build packs come in. Build packs are a cloud native computing specification that were designed to make it easy to take an application artifact, such as a .NET application, a Python application, a PHP, a Ruby, or Java or whatever style application, and turn it into a container. They're great because they can make it easy for me to not have to worry about all the stuff I don't want to worry about, right? Stupid stuff like how to containerize my application. There's even a Maven plugin that you can use that will do this work for you. So you can say Maven spring boot : build - image, and there's a parameter that you can specify to specify the name of the Docker image, and then you can just Docker tag and Docker push that application. This is great. I like this, but I also want to take my Java virtual machine application and turn it into a GraalVM native image. And the reason I want to do this is because GraalVM makes it easy for me to create applications that have a much smaller runtime footprint. And GraalVM is very powerful, right, in this respect. It has a faster startup time, right? But keep in mind, what GraalVM does is it's a ahead of time compiler. So it's going to look at all of your source code, and it's going to look at all of your .class files and all the jars, and it's going to look at everything in the JRE, and it's going to say, based on my analysis of your code at compile time, I don't think this class, and this class are going to be needed. So I will throw them away. We won't have them in the memory of the native heap that gets generated when the application is compiled. This is okay for simple applications, but remember, Java is a very dynamic language, right? It may feel like C or C++ or something like that, but it actually has a lot more in common with JavaScript and Python and Ruby and Lua and these very dynamic scripting kind of languages, right? You can very easily take a Java string, turn that string, as a class file into you can compile it into a .class file, load the .class file into the class loader, create a new instance of that class using reflection, Java lang reflection. You can then create a invocation handler proxy of that type. You can serialize an instance of that type. You can write it to a disk and load it on another virtual machine. And all this time, you'll never actually have a concrete typed reference to that thing. It's all through Java lang object references, right? That's amazing. It's not quite as powerful as eval, E-V-A-L in other languages, but it's pretty darn close. And that should tell you a lot about the power of Java. And so you need to be aware of that. The entire Java ecosystem uses this kind of dynamic behavior. So you need to tell your GraalVM compilation about the dynamic things that you're going to do at runtime that it couldn't possibly see at compile time. Things like proxies, like reflection, like serialization, like loading a resource from a jar. All that stuff doesn't work unless you provide configuration. So we have a project called Spring Native. Spring Native is designed to make it easy to, for as much as we can, tell GraalVM about the nature of the dynamic things that your application does. And it's also configured to work with build packs. So you run the same exact command, that Maven Spring Boot build image, and you'll get a dynamic application, a dynamic container. And I've already got this whole process here. I'm not going to run it in my local machine because it takes memory and time, and we don't have much of either on this little machine of mine. But basically, I have a little script here in my GitHub Actions, which is completely open source. You can check it out. And it just does this, right? So I'm deleting the image of my local Docker cache. Probably don't need to do that. And then I'm running a Maven Spring Boot build image. I'm specifying the build image name. So dcr.io. My Google Cloud project, and then the name of the app, in this case, customers. So this takes about, I don't know, 8, 9, 10 minutes. Let's see what the last one is. Here, deploy. I ran it at 35 minutes ago. It took 11 minutes, the whole pipeline. And most of that work, my friends, is just running the Docker image, right? So, you can see it's just doing Docker, and then GraalVM. All that stuff is happening inside the Docker image. So I get a Docker image. I get a build that happens inside of a Linux container. So even if I ran this on my Mac, I would still get a Linux image in a Linux container. So that's great for production. And then I can deploy that. So let's see here. We kubectl logs deployments. Okay, customers deployment. And did it connect? Did it start? There you go, 0.3 something seconds. And you can see it's running inside of Kubernetes, right? So this is an example. You can run the code yourself and try it out. It's basically the same as what we just typed here. Okay, so that solves that problem. Now I have an application. I want to build another Docker image. I want to build another microservice, and this one will be to manage order data. Now I could use HTTP, but I much prefer RSocket. I'm going to use Java 17 here. RSocket orders. RSocket is a binary protocol that is it was created by engineers at Facebook and Netflix. That's designed to make it easy to get around the limitations of HTTP 1.x and HTTP 2.x and gRPC. It's a very fast, very flexible, reactive protocol. It's binary, it's bidirectional, so it doesn't matter which side connects to which side first. It supports fire and forget, request response, streaming, bidirectional streaming, communication. Very, very useful protocol, very, very powerful protocol. And we're not going to spend too much time here, but I've got a whole other talk called Beautiful RSocket that you might look at. But what we're going to do is we're going to create another controller here called the orders RSocket controller. Okay. And we're going to have a constructor. And I'm not even going to bother with a database here. I'll just use an in-memory map of data. Okay. I'm going to create a collection of order records. So we'll use Java records here. Integer ID, integer customer ID. And we'll say order db equals new concurrent hash map, and voila. Okay. Good for us. And I'm going to say for var customer ID equals 1, customer ID is less than or equal to 8, customer ID plus plus, and good. So we're just going to, in this loop, in this body, we're going to create a list of orders, right? And we're going to create an array list, and we're just going to create a dynamic, random number. Okay, so var max equals int math.random times 100, and I'll say for var order ID equals 1, order ID is less than or equal to max order ID plus plus, and I'll say list of orders.add new order. Okay, so that'll be order ID on the left, customer ID on the right. And for once that's done, I'll say this.dve.put customer ID on the left, list of orders on the right, etc. So now, whenever somebody wants order data, they can come to our RSocket endpoint, and we'll just serve it up to them like this. We'll say, okay, here's a endpoint message mapping orders CID. Okay, publisher of type order, get orders for destination variable integer CID, return this.dve.get CID. Okay, so that's a list. I'm going to turn this into a reactive stream, thusly. Okay, so that's just reactive streams. It's another protocol. I have the controller annotation. This is the same annotation you use for WebSockets, for HTTP, for service and event streams, for GraphQL, etc. Remember, this is not tied to HTTP. It's for general purpose controllers. Okay, so that's done. Now I need to expose this over a port, and so I need to specify an RSockets for port. I'll say 8181. We'll go ahead and run this like that. Okay, there's my application. It's up and running. Now I want to go to here. I'll say localhost. Sorry, I want to go to the command line because it's not HTTP. So we'll say RSC TCP localhost 8181. Route is going to be orders.to. The interaction type is going to be a stream, etc. And there's my stream of data for my orders records. Okay, so I'm just using RSC. I'm using this client like curl to talk to my RSocket endpoint. I've got my HTTP endpoint as well. We saw that earlier here. Is that still running? That's the question. Did I stop it for whatever reason? I think I did. Okay, so we've got now our two different endpoints. Now I'm going to build an edge service. And so we're going to go back to start.spring.io. And here we're going to create a new service called Edge. And an edge service is a service that lives at the edge of your architecture. It is meant to be where requests come in from the outside world. It's a great place to handle redundant concerns, things like routing, compression, security, etc., in a central place. So you don't have to redo them for every single microservice. You can, DRY, do not repeat yourself. This is a very useful pattern. We can also accommodate different clients, right? You might have, let's say, 10 microservices or whatever. Well, rather than changing each one of them each time a new client gets introduced where they have a new use case, you can instead create a new view of the data, a new API adapter or API gateway to give the client a particular view of the data, okay? And you're gonna find that this is a very common thing. Netflix, for example, created edge services for every new client. And I'm sure you can think of an ecosystem or an experience where you can use Netflix in your life, right? Netflix runs in the TV, runs in the iPad, the iPhone, the cars have it now, refrigerators have it. I mean, it's everywhere, right? So imagine having to change every single microservice in the organization whenever a new client gets introduced. That's not going to work. Okay, so here's our edge service. Our edge service is going to use Spring Cloud Gateway. It's going to use the reactive web support. It'll use the RSocket support, and it's going to use the GraphQL support. Unfortunately, that isn't yet here. Okay, so we'll have to do that manually. Let's go ahead and open this up. Edge.zip. And all I'm going to do is I'm going to go back to my edge. I'm going to choose 2.60 RC1. I'm not going to use the new build, but I do want the new plugin repositories, the milestone repositories for the not yet GA Spring GraphQL project. Okay, so I'll paste that in there, and I'll go to the edge. So source main Java edge, and I'm not going to import this yet. We'll leave it not imported to GraphQL. I'm going to create some DTOs, so customer integer ID, string name, record order, integer ID, integer customer ID. Okay, good. Now, what we're going to do is we're going to create an endpoint that gives the client a view of the data. One thing you might want to do is to create an API gateway, and you can do this easily with Spring Cloud Gateway. So route locator gateway, route locator builder RLB, return rlb.routes.build. .route.build, and the route defines how requests that come to this edge service, in this case on port 9999, get handled. So we're going to say when a route request comes in on port 9999 with a path of proxy, then we want to send the request to the downstream 8080 microservice. Okay, so this is a very simple experience, a very simple example, but you can do interesting things here. You can say I want to have another predicate to have the presence of a cookie or a header value, or the host name has to be a wildcard, a vhost, that kind of thing. The problem here is that we're going to handle incoming requests with this path proxy, and we're going to send it to this request to this URL /customers with a different path. Well, that won't work. Localhost 8080 /customers /proxy does not exist. So we need to use a filter, and the filter we can use to change the path, for example, right? This is the real power of Spring Cloud Gateways. I can use the path. I can say add response header, HTTP headers, okay, like this, HTTP header .alaxis control out origin. I can do retry, I can do a redirect, I can do all sorts of things here. I can do rate limiting, right? Request rate limiter, right? This is great if you have too many downstream services. You can plug in a Redis rate limiter. So there's just a lot of really interesting things you can do without actually writing much code. I'm using the Java API here, and I'm just this is just one route, but obviously you can create as many route definitions as you like. But there's also a property file syntax for this and a YAML syntax for this. And you can go a step further. You can store this gateway configuration in YAML or property files in an external source, like your Spring Cloud config server, or Vault, or HashiCorp console, or Apache Zookeeper, etc. Pardon me 1 second.
Okay, so colleagues, thank you very much. While Josh is resolving that issue, I'd like to encourage you to ask your questions, even if you're asking in Russian, no worries. I will translate it. So, Josh, please proceed.
Sorry about that. I had to quickly take
no
care
worries.
of one thing. Okay, so I am going to, I've got my gateway here. I've got my filters. It's a very simple gateway. We can go ahead and let's start this one up. Here we go. And I'm going to need to call it. So I'll say terminal, okay, curl -h host hello .spring.io HTTP localhost. What did we say? 9999. Okay, 9999 / proxy. Okay, there's my data. It worked. But if I change this to be like spring.org, it doesn't work. We get a 404, right? So that's working as we expect to. So Spring Cloud Gateway, very powerful. Lots of things you could do there. But this is great for when you're proxying data, when you're taking data from one thing and sending it on to the other without changing it too much, right? What if what if you want to create a new view of the data? What if you want to take the data from the downstream service, transform it in some way to accommodate the client, right? Again, there's a lot of reasons why you might do this. Imagine you've got an Android client and an iPhone client. Should they both learn to speak HTTP and RSocket? Should they both be authenticating? What about the composition of the data? Is it efficient to make the Android client going through a tunnel to take the data from over here and the data from over here and create a new view out of it? Or wouldn't it be better to do that kind of composition, that service orchestration from the server side, and then send back only the resulting view for the client itself? So it's much better to do these kinds of transformations for bandwidth efficiency and for simpler code and maintenance, among other things, on the server. And so I'm going to create a client here that allows me to work with that data. Okay, I'm going to create an endpoint here called order, get orders for integer customer ID. And we're going to say flux.empty, and we're going to say publisher customer, get customers, return flux.empty. So what I want to do is I want to call these downstream services. One's an HTTP service, so I use the reactive non-blocking web client, and another one's an RSocket requester, and also I'll use the RSocket client, and I will inject these into my constructor, which I'll create here. And I need to actually build these beans, right? And you can see that they have a fairly similar structure. For RSocket, remember, RSocket is a stateful protocol. So once the service starts up, it connects to the other side and it stays connected. It doesn't need to reconnect for every single question or query that you send it. You just have one multiplexed socket through the life of the application. We're also going to create a web client build. Okay, so there's my HTTP non-blocking client, and here's my non-blocking RSocket client. I'm going to use those here to make these requests across the wire. I'll say for the HTTP endpoint, I'm going to make a call to localhost 8080/customers, retrieve the data that comes back as a type of stream. And for the RSocket endpoint, same thing, right? I say this.rsocket requester.route orders CID customer ID dot retrieve flux order dot class, etc. Okay, so there's my basic interactions. Now, these are both just reactive streams of type T, and I don't really have to care after I've done this how that data comes or what time, what speed it comes, or whatever. And if something fails, I can use the reactive streams operators to make the code more robust. Okay, so on error resume, when there's an exception, just return an empty stream. I can do a timeout, for example. I can say do a timeout here of seconds, etc. So these operators are not part of RSocket. They're part of the reactive streams implementation called Reactor that underpins everything that we're doing here. Okay, so we've got this these two different network calls that we're making. I don't know if these are appropriate operators, but you can see that you can do the same thing, right? It's very easy and consistent. Now, I want to compose this data to create a new view of the data with both the customer data and the order data. So I'll create one called the customer orders, okay? So customer will be on the left, list of orders on the right, okay? Goody. And we'll create a new endpoint here to return the customer orders. Goody. So we'll say return this.customers.flatMap. Now I've got a customer, and what I want to do is I want to take each customer and create a tuple. A tuple is a bit of memory where each element, each item in this thing has its own type, like an array, but where each index type or value rather has its own type. So the thing on the first spot, I will say is a customer, mono.just customer. Okay. The thing on the second spot, whoops, not C, I need customer. The thing on the second spot will be the orders data. So I'll say customer.id. I want to collect that into a list. Okay, so that gives me a tuple back. I'll say map tuple to, okay, new customer orders, tuple2.get T1, that's a customer, tuple2.get T2, that's the orders list. Okay, so see what I'm doing? I'm taking the customer's data, and for each one of them, for each customer, I'm creating a tuple, and the tuple has two elements, this and this, and then I'm taking that tuple of two elements with a customer and a list of orders, and I'm creating a stream of customer orders from this, right? So it's very, very simple logic. It's for each customer, get the customer and the orders, and then create a customer orders out of that, those two pieces of data. But I'm also making, concurrent network calls. I'm also making network calls that might arrive and finish at different times, and yet I don't have to worry about all that. This is the most efficient version of this code. Could I do better by having an endpoint where I can say, here's all the customer IDs, give me all the orders? Yeah, probably, right? But for this particular thing, which is an N+1 solution, which is not great, for this particular thing, at least it's doing everything that it's doing concurrently because it's reactive, right? And so I'm not wasting time serially waiting for each response to come back before I can get the next batch of results. This is the most efficient version of this code. So we can try that out by creating a simple CRM REST controller. Okay, at response body, get mapping COs, publisher of customer orders, and I'm just going to inject that here. I'll say CRM client CRM into the constructor. Turn this.crm.get customer orders. Get customer orders. Okay, there we go. There's my CRM REST controller. Let's go ahead and start this edge service up again. Localhost COS. Okay, so there's the customers, the orders, etc. It's working great. Okay, so I've got my data at the same time. I can see the customer data and the order data in the same response. This is a view that's perfect for my client, which doesn't need to care about the fact that there's RSocket over here and HTTP over here. It just works, right? Okay, now, is this going to be something that I can keep doing forever and ever and ever? Of course not, right? I don't want to have to create new views of the data every time we create a new client. Hopefully, you'll figure out some views that work for a lot of them. But at some point, wouldn't it be nice if the client can just ask for what it wants and get it what it needs and nothing more? And this is the problem that Facebook had. Facebook wanted to create small, singly focused, independent microservices, but they want their clients to have all the data in one place, in one view, as quickly as possible. So they want distinct, separate microservices, but they want the client to have all the data in one place, right? And there's a tension there, there's a conflict. And so they were trying to figure out what's an easy way to solve this problem so that they don't have to constantly reinvent these edge services. And they created something called GraphQL. Now, GraphQL was created in 2012. It was open sourced in 2015. And it's a very nice way to describe orchestrations or data integration layers. And so we're going to use the Spring GraphQL project. I'll finally go back here, and I've got the milestone dependencies down here. And in my build, I've got gateway. Do I have the GraphQL stuff in here? Wow. I don't even know if I have RSocket, WebFlux, gateway. I don't think I even added that. So let's add that GraphQL dependency. GraphQL Spring Boot Starter. Okay, so that's a not yet GA, but it's built on the GraphQL Java library, which is the same library that powers Twitter, for example. Okay, so it's very, very scalable. Now, GraphQL is very ubiquitous, right? You've probably seen the SpaceX GraphQL API. I can just run this and it gives me all the information. But if I don't want, excuse me, if I don't want all this extra data, I don't need it, right? I can just ask for just the data that I want and I get that data back, right? And it's introspectable. So I can ask for the details. I can ask for, whatever I want. I only get the stuff that I use, right? I don't have to pay the cost of querying for these things, even though these are all probably different microservices running on different machines, doing different things. I have one view of the data, and I get control space, I get navigability, I get schema. So it's a typed, introspectable, really efficient way to integrate APIs. So I'm going to create a directory here called GraphQL. In this, I'll create a new file called schema.graphqls. Okay, and there I'm going to create a root type called customers, or sorry, called query. And query is the root type off of which your domain types will live, right? So I'll say ID, customer ID, sorry, name, string. So this is the the GraphQL type for my domain model. Okay, I'm creating another one here called ID, and then customer ID, and then I'll say I want to get all the orders for my customers. So remember, before I had customers and I had orders, and they're separate microservices. But logically, even though that's true, and even though there's a reason for that, I still want to present the orders for the customer data. So I'll add a field to the customer type. Okay. Now, this requires a call to the orders microservice. So if you want to pay that cost, you can, but if you don't, because it's GraphQL, you can just not include that in the response and it won't be returned and it won't resolve anything for you. Okay, so it's more efficient. So we've got this basic type system. Now let's create the GraphQL controller to deal with that, right? So let's say CRM GraphQL controller, and I'm going to use the CRM client here yet again. And okay, so we've got a type called query, and we want to return all of the customer data for the customers field, right? There's a field here called customers. And so we can say customers. And here we're going to say return this.crm.get customers. All right. Now, what about the data for the customer? Well, we create another mapping here, another resolver, if you will. And I'll say the field is called orders and return the order data. I need a pointer to the customer to be able to resolve the orders for that customer. So I can say to GraphQL, please inject that customer data, and I'll use that in arriving at the orders for that customer, right? So customer.id, okay? Okay, so that should work, right? That'll give us all the customers for the query, and then for all the orders of the customer, that'll work as well. Now let's see what would happen if we run this. Localhost GraphIQL. Oh, sorry, it's 99.99, my edge service, not the customer service. All right. So there we go. There's my GraphQL editor, just like SpaceX. I can now say query customers ID, no problem. Give me the name. Okay, no problem. Give me the orders, and the orders data has IDs. Okay, no problem. What about the customer ID, etc. So, but you can see I'm not paying. I don't need to get the orders data. If I don't ask for the orders data, then the order service is never involved. It's never invoked. So the client can ask for what it wants, and it gets what it wants. The other thing that, I just showed you how to read data, but GraphQL also supports mutations. And this is one of the things I love about GraphQL is that, there's only one kind of mutation. There's no arguments about it. There's no, is this right or is that right or whatever. It's just very clear. This is not REST. This is definitely not REST. In fact, you can use GraphQL with WebSockets. You can use it with other protocols in theory. I hope that we'll see GraphQL support on top of RSocket. Because it's not REST, there's only one way to mutate things, to change something on the server. Those are called mutations. And there's no argument about whether you should use post or put. There's no discussion around whether it's HTTP 200 or 201 or 202. It's just one thing. It's very simple. It's very easy, very focused on production. So my friends, we've looked at a few things here that are designed to help you write software better, intended for production. We've looked at patterns here in Spring Boot itself to support running and deploying to a production environment. We looked at things like reactive programming. We looked at things like build packs. We looked at things like Spring Native and the GraalVM support. We looked at the Spring Boot actuator to support observability and project micrometer to support metrics publication and consumption. We then looked at RSocket, which is a reactive binary protocol. We then looked at Spring Cloud Gateway. We looked at reactive programming as a way to do service orchestration, scatter, gather, service orchestration and composition. And then we looked at GraphQL as a way to do data integration. And I've been using GraphQL here. And by the way, I created these schema endpoints, these endpoints here. This is a common thing to have a handler for a type query. It's so common, in fact, that we just have query mapping. And actually, we can figure out the name of the fields from the name of the method. So you can just comment that out. This is exactly the same as this. This is query mapping, which is schema mapping with type query, right? So this one still works, but you have other mapping methods like @mutation mapping and so on. And we looked at Spring GraphQL because I can just return these reactive resolvers. And so I'm doing concurrent service orchestration and composition, just like when I did the manually reactive endpoint, the custom orders view. I get the best of both worlds. It's very clean, easy to code, to understand, but it's also the most efficient code that is possible. So my friends, I hope you got something out of this. I hope you learned something. I'm very happy to have some questions and to hang out and chat with you.
Yeah, thank you very much, George. Thank you very much for amazing talk. That's really makes my morning. Okay, so we have a few questions in our chat. Let me start. So Grigory is asking, are there any reasons, just like maybe it's just a joke, are there any reasons to use Maven in 2021, or it's just a matter of your personal preferences?
Well, for one, as far as I know, Gradle doesn't support Java 17, which is a little awkward. Is that fixed yet? Let's see. Gradle, Java 17. Nope, Java 17 and later versions are not yet supported. So that's one reason. The other reason is just I don't care. I mean, use whatever you want. It's not the hill. You know, in English we say it's not a hill I want to die on. I don't care. You can use Kotlin and Java or Groovy or Maven and Gradle, and I'm very happy just as long as you're in production fast, you know. Yeah, I don't care. Most people use Maven, very large majority. So in this context, on the server side, it just seems reasonable. But in the Android space, yeah, of course, I would use Gradle.
Yeah, thank you very much for your answer. Okay, so Mikhail, what else do we have in our Q&A chat?
Yeah, we have a question from Michael. It's a big question. I will read it. What do you think about the fact that by using Spring or any other too high-level framework language, engineers stop to be curious on how actually things works, how to optimize code and etc. And then that leads to a problem that any slightly harder problem treated as unresolvable magic. Point.
So I mean, there's certainly trade-offs, right? So I don't say that anything is unresolvable. That's quite the contrary. I and millions of other people know what Spring is doing because we've used it and we have skills that are built around it. Whereas if I had built the same thing myself, then nobody would know what it is except for me, right? So that makes it less valuable. Remember, software is a team sport. So instead of playing your own game, your own custom game, you should just play the game that everybody else is playing. You should use a baseball or a football or a soccer ball or whatever. That way everybody can play together, right? If you make up your own rules and go by yourself and have your own game, it's not as productive, right? You're not going to be very valuable by yourself, and you're going to make it harder for other people to play with you. That said, I can appreciate that it may seem at a sufficiently high level that it's unresolvable. So it's worth taking time to learn about Spring Boot's auto configuration. Once you've learned about auto configuration, things become much clearer, right? It's a much more clear why something is happening. And Spring Boot auto configuration is also, you know, it gives you productivity. It gives you a lot of benefits because you don't have to worry about things that would be boring. There's stuff that make me fall asleep, like how to get a web server startup or a connection factory. You know, I don't care. I just, it's not why I woke up in the morning. I did not wake up excited to worry about how to start up a web server. I want to build an application that solves a problem. And so the trade-off is always there. And I think the trade-off is worth making. And there's nothing that's free. You would have to learn anything to do anything, right? So good question, though. You know,
That's really a great point. Thank you very much. We have another one. I don't know, it's joke or maybe. Is it possible to create a layered jar with build packs?
Layered jar? Yeah.
Yeah.
So I'm not sure about build packs, but you can definitely do it with the Spring Boot Maven plugin, where you can specify the layers that get plugged in. You can say, I want the libraries to be in this layer. I want the, you know, the .const files for my application only in this layer, and so on.
Thank you very much. Alex?
Okay, yeah. So we have a few more questions maybe to ask. So first of all, it's a question from our anonymous attendee. So he says that, or she said that the start of Spring.io has become our prayer for the question. Java 17 supports for Kubernetes native, when it's coming, and if it's okay to take it in production once it is globally available. So I suppose it's a question about, is it okay to use Java 17 in production? Because as far as I'm aware, it is already globally available. So what do you think? Should we start using it right now, or just wait for first service pack, as it ordinarily said?
Java 17, yes, but Java 17 and GraalVM, not yet. I think they literally just released it like last week, right? So we have to update Spring Native. We're working on that. But if you want to use Java 17 in Kubernetes, absolutely feel free to do it. It's great. You just wouldn't, it's not recommended to use it for GraalVM native images yet.
Okay, yeah, great. Thank you very much for your answer. And last one, a question from our chat is about all the amazing things you demonstrated. So Peter says that you demonstrated a lot of cutting-edge technologies here, like native images, RSocket, web plugs, and so on. So does it make sense to use all these things in production? And when should we start using web plugs instead of our cozy Spring MVC, cozy Spring MVC, or start using RSockets instead of transparent REST?
That's hard. Obviously, first, most important thing, if you're in production and your scale is fine, maybe it's fine to just leave it where it is. Don't throw stuff away. If you are trying to make the process of writing code that is more reliable, more robust when failures happen, and it's also more scalable, then of course moving to reactive will help you there considerably, right? If you have to do lots of integration code, then moving to reactive will greatly simplify the code base. So and that's not, it doesn't matter in that case about performance, it doesn't matter about scalability, it's just very convenient. If I could build a brand new application today, all my microservices would be RSocket, but the edge, of course, would be some sort of HTTP layer like GraphQL, right? Or maybe even not GraphQL, maybe just HTTP and REST, because the world outside doesn't really speak RSocket. There are RSocket clients for Android and C++ and iOS and JavaScript and whatever, but practically speaking, it's probably just easier to use HTTP at the edge. So yeah, for me, it's about keeping my code clean. It's about efficiency. But if your code isn't particularly complicated and you're not having trouble meeting the demand, then just stay where you are. It's fine. It's not going anywhere. It's not like we're throwing away Spring MVC or anything like that. It's fine. And you can actually use Spring MVC and use reactive types on top of Tomcat. By default, we're using Netty when you use Spring WebFlex, but there is a kind of a hybrid mode that's pretty interesting.
Okay, so thank you very much for answering this question. As far as I can see, there are no more questions in our Q&A section and no more questions in our chat. So thank you very much for joining so late, because as far as I can see, it's still Monday there. It is already Tuesday here. So thank you very much for joining our conference.
Thank you so much for having me.
Yep, we're very happy to see you here. Okay, so dear attendees, today we have one more session. It will start 7 p.m. Moscow time. There will be a session about Kafka in multiple data centers. If you have any other questions to George, okay, so he left our conversation. That's why. Thank you very much, everybody, for joining. I will share the recording shortly. So that's all. If you want speaking to us, you can unmute yourself and ask your questions. If not, thank you very much. Have a nice day and bye.
Bye.